So hi everyone, sorry for the small hiccup, and again welcome everyone to this IKDD Data Science Meetup, where our topic for today is large language models. Where are we now and what lies ahead, right? So we have an interesting evening lined up for all of you, starting with two talks from distinguished speakers whom I'll introduce soon, followed by a panel discussion moderated by me, and then a breakout where we'll have focused roundtable discussions, right? So as we all know, right, around November, once ChatGPT came out, right, we all had our reactions to it. We were wowed by it. We were worried about it, and the reactions ranged from, on one hand, like, how do I use this technology and build the next unicorn? On the other hand, let's stop everything to do with LLMs. We should not allow LLMs to be trained because there's an existential threat, right? And then somewhere in between, where we were worried about, hey, we have LLMs, they work for English, but what about my languages? What about Indian languages? To the other side, hey, these LLMs have come, and India is one of the major areas of export that we have is our IT industry, where a lot of code gets written. What will happen to all those jobs, right? So we have covered the full spectrum. A lot of confusion, a lot of fear, a lot of excitement, a lot of emotions from both the ends of the spectrum, right? So it would be interesting to discuss many of these things today. Some of these topics will be covered in the talks that we have. Some of them will be covered in the questions that we'll have during the panel discussion. And then, of course, a lot more will be covered in the focused roundtable discussions. So let me start by introducing our first speaker for the day and the first talk, which is on towards inclusive large language models by Partha. So Partha is a senior staff research scientist at Google Research, Bangalore, where he leads a group focused on natural language processing. He's also an associate professor at IISc Bangalore, currently on leave. And before this, he was a postdoctoral fellow in the machine learning department at CMU. And he received his PhD before that in 2010 from the University of Pennsylvania. So he's broadly interested in natural language processing and machine learning, and he has also received several awards in this field, including an outstanding paper award at ACL in 2019, and more recently in 2020, the ACM India Early Career Award, right? So really happy to introduce him and really happy to have him with us today. He's also co-author for a book on graph-based semi-supervised learning. So I'll hand over to you, Partha, for the first talk on towards inclusive large language models.
Yeah, thanks, Mitesh. Let me share the screen first. Okay. Mitesh, are you able to see the screen in full screen?
Yeah, it's just loading for me. Yeah, okay. I can see it now.
Okay. All right. Second. Yeah. Okay. So yeah, thanks, Mitesh, for a generous introduction, and thanks, Srujana, Lavanya, Raj, and of course Mitesh for having me here. So this is a very timely topic. I'm sure many of us are kind of thinking about it, working on it. So looking forward to kind of sharing my thoughts and learning from all of you, and looking forward to the discussions. So so today I'm looking at kind of one aspect of large language models and how we can make them more inclusive and cater to broader segment of the society. And I'll take towards the beginning kind of general introduction just to lay the context, and then move on to some of the India specific things and what we need to do to make LLMs work in the Indian setting. So just to make sure we are on the same page in terms of terminology. Large language models are basically large general purpose models which can be pre-trained and then adapted or fine-tuned for specific tasks, right? And those tasks could range from classification, conversational, kind of reasoning, and more recently coding-based problems as well. And then the large could mean be in terms of like the number of parameters of the model, the size of the model, or the amount of data that the model is trained on. So these kind of the LLMs, how they are trained, there could be kind of like a few different variations. One could be based on some sort of perturbations in the input text, where you basically create some sort of changes to your input sentences, and then maybe you are trying to fix those sentences or predict something that's masked, or other kind of more generative models where given some context, you are trying to predict maybe the next token or the next segment, right? And these models will work with usually sub word units, which are also called tokens, and then they will try to do, say, the next word prediction in the purely generative setup. So there's a lot more to talk about this, and this is not a tutorial, but if you're interested, you can go and look at this, a few videos from Google that was kind of released recently that can give you kind of some more context. So given, and then I guess one of the benefits of or how this kind of models have been billions of these parameter models have been trained on large amounts of data because of the self-supervision setting, where you create all of these kind of learning problems purely from unlabeled data, and that has enabled to scale these kind of models to trillions of tokens of corpus, right? And performance have been impressive, we have all observed in one way or the another. So these kind of models are able to explain jokes or do logical inference. For example, in this particular case, it's saying Shelley is from Virginia, but is visiting the city with that famous market where they throw fish, going home next Tuesday. So the question is it likely that Shelley will be near the Pacific Ocean this weekend, right? So you just give this as the input, and everything that you see here in blue are the model output. So in this particular case, the PALM model, and it's able to say that this fish throwing tradition is there in Seattle, and Seattle is close to Pacific Ocean. And since Shelley is going back home only next Tuesday, so this weekend she is likely to be in Seattle, right? So as you can see, there's multiple hops of reasoning that are needed that at least these models are able to demonstrate. Not only on pure text problems, but even on coding related problems where you're asked to, the model is asked to write a function to check if a particular string is a palindrome in JavaScript in a particular language, and also give line-by-line comments, not only in English, but in Malayalam, right? So in this case, this is an output from the PALM2 model. So you can see that these kind of LLMs performance goes beyond the natural language into the coding domain, and also to some extent in the multilingual space, going beyond English. And work streams that usually that you work with while building these kind of models is that there is an initially data preparation stage where you curate and clean data, which is a really important stage in terms of what kind of exposure your model is going to have. So lots of time gets spent at this stage. Then comes the pre-training stage where most of the compute heavy lifting happens. And at the end of this, you get a pre-trained model that you then fine-tune, either based on some label data or in some active way based on human feedback. You kind of train the model, align that with your values. And then finally, once the model is trained, then you evaluate based on whatever tasks and evaluation data you have. And this is kind of like an iterative loop, right? So once you have done the evaluation based on the errors that you see, maybe you will go back and add some more data or fix some issues, and then the process goes on and on, right? So this is kind of roughly at a very high level what work streams in LLMs are going to look like. So next I'm going to transition into what's the relevance of all of this in the Indian context, and what we should do, and many of the concerns that Mitesh also shared, but I'll be looking at kind of like the inclusion and linguistic inclusion dimension in there. So India, thanks to cheap data and wide connections, internet connections, smartphone availability. So we have 850 million internet users. This is the statistics from TRI last year. But only about 10% of our population can speak English, have some knowledge of English. This is based on the 2011 census. But when you do market research and users studies, you find that there is lots of people who want to engage with the web, experience the internet in their own language, and disproportionate number of them prefer to engage in local language, local languages, which is different from English, right? And so the point of this slide is that there is a great appetite in terms of benefiting from the web and using computing in a language of their choice, which for vast majority of the population is non-English, while most of the capabilities that we see are in English. I mean, of course, there are coverage of other languages as well, but I think we need to go deeper along that dimension to serve this population well, right? So now when I think about LLMs and relevance in India, so it feels that it's kind of yin and yang kind of situation, right? So right now, we have these amazing performances from when you use English, and that part of the population is served well through these LLM models. Maybe for a few other languages, things could work, but beyond that, there is a big cliff, right? So if you let things run as is, then I think there is a serious risk that LLMs may increase the digital divide in our society. So people who know a subset of the languages are going to be well served, while the gap with the rest of them is going to increase, right? But at the same time, I also think that LLMs and the multilingual large language models are also I think the best tools that we have at our disposal for improving inclusion, and in particular linguistic inclusion, and make information more broadly available to a larger segment of the population. But this is not going to happen automatically, because if it happened automatically, this would be in that as is bucket. So this is going to require additional focused effort, and this is not just kind of an operational effort. I feel that there are deep research problems that need to be solved if we really want LLMs to serve Indian population well. And I'm using India as an example here of a global south, because many of the things that we develop here hopefully will be useful elsewhere as well. So very quickly, we are a nation of huge linguistic diversity. According to last census, we have 1,300 plus languages, lots of scripts, 1.3 billion plus speakers. We have 60 plus languages with million plus people, 22 scheduled languages. And on top of that, it's very common for people to know multiple languages, and they end up using those languages even in the span of a single sentence, resulting in a phenomenon like code mixing and all, where many of people in the audience, including Monojit, have done lots of seminal work. So and all of these produce challenges for these kind of language models, and we kind of think of this say even for Hindi as a big monolithic language, but turns out that there are 40 plus related languages and dialects within this Hindi block of of our population, right? So lots of nuances here that we need to cover in this diverse landscape. So so what do we need to do, and what are kind of the challenges? I'll be mostly raising questions and not so much of solutions. So one is that the success of all of these language models have been enabled because of availability of large large corpora in the languages of interest, right? So so if you have corpora in your domains or in the target languages that you want to cover well, I mean, if, the current methods could work pretty well, and the cross-lingual generalizations that we see in these models are quite remarkable, right? So if you have large corpora, I think we are pretty well served. But the problem in the Indian setting is that a lot of our life and activities, culture are not very well represented on the web, right? So the corpus itself isn't there. And if you see Wikipedia as a yardstick of how much corpus is there, I mean, you see that for English, you have 6.6 million articles in Wikipedia. I think for Hindi, this number was some 160,000 or so, right? And for languages like say Oriya, which is spoken by 10 million plus people, you have some 10,000 or so Wikipedia pages, right? So capturing all of these local knowledge, local nuances become very difficult when you don't have this kind of corpus in place. So one approach here could be that we develop methods which are more resource and sample efficient, better pre-training strategies, which could work with lesser amounts of data, maybe leverage the relatedness among the languages that are there. So all of those are possibilities and important research questions that need to be kind of undertaken in the Indian context, and similarly for other low resource regions. So while I'm talking about text, so one effort that we have in terms of creating resources in the speech domain is this project called Vani, which is trying to capture the speech landscape of India. So this started with the motivation that I mean, speech is like a continuously varying phenomenon. So even if you're speaking Kannada, the way you speak Kannada in South Karnataka versus North Karnataka, that's going to vary. So rather than anchoring on these languages, why don't we anchor on regions and collect this data? So this is a project that's being run by Institute of Science, IISc, and Google is funding the project. So the idea is to collect image anchored speech data, image prompted speech data, but anchored on regions, by collecting about 200 hours of speech from each one of the 773 districts in the country. And about 10% of this data will be transcribed, and then all of this data will be made open source. And you can go and visit the vani.isc.ac.in page for regular updates and then release of the data. So this is one effort to capture the data landscape, especially on the speech side, and some amount of text that's coming through transcript. And I think we need more such efforts, both on covering the data and also modeling part. And through Bhashini, the work that Mitesh and others have been leading to create these kind of data sources is also, I think, going to be tremendously important. So now moving on to the evaluation, which is a huge problem, right? I mean, I would say even for English, especially for generative content, long form generation, how do you have metrics that can reliably and faithfully evaluate your responses is a problem. So all of those things, and both for English and for other languages, that's a challenge. But beyond utility, we also need to be conscious of evaluating from a responsible AI perspective, from a fairness bias perspective. So I just want to highlight one piece of work that we have been doing in that space of recontextualizing fairness in NLP, and then creating benchmarks by keeping fairness and bias and responsible AI as a first order consideration. So you may ask why we should be bothered about that. So even the limited amount of work that has happened in the fairness and bias analysis in NLP, that has happened within Western lens. And this is a quote from this seminal paper from Samba Shivan et al., where they said that a lot of this work have happened within Western lens. So while we share some axis of discrimination with the West, but we also need to recontextualize because we have like an additional axis of discrimination, like say caste or regionality and so on and so forth, right? So in this ACL 2022 paper, we laid out a research agenda to create these kind of evaluation data sets and benchmarks and recontextualizing like fairness to these kind of like different regions, keeping in mind the societal context or like the technological gaps that's there and the value alignment, right? Because I mean, if you are developing and evaluating these kind of like models and their outputs, they need to kind of like conform to local values and like local jurisdiction frameworks. So we have also released a data set focused on stereotypes in the Indian setting. So that's available at this QR code on GitHub. But the point is that like cultural recontextualization is important because you want to make these things available in the local context. There is some work where we have shown that even using LLMs, these kind of seed data sets could be amplified to larger sizes. And it's really important that we also engage with communities to kind of like who have lived experiences, so that their voices and their experiences are reflected in the evaluations that we do, right? So since there might be like many students in the audience, I thought I'll like list a few problem synthesis topics. So one is that like why and how these like LLMs work. That it itself is like a big open question. How we can scale these types of models with little or no corpora at all, I think is a very interesting and important research problem. Because like the standard hammer for training large language models is that I need large amounts of thankfully unlabeled data, but for many of these languages we don't have even that to begin with. How we can leverage different modalities, right, for linguistic inclusion, because the availability of these kind of say text, speech, and other modality data in different languages could vary. So how we could leverage all of that. Representative benchmarks and how we can do evaluation in a meaningful manner while keeping like the responsible AI aspects in mind is super important. And how we can engage with communities. So while we develop like these kind of like technologies with inclusivity in mind, right? And then once we have detected some biases in these models, how we can rectify or like mitigate these kind of problems. So with that, I want to like close this by introducing you to Sharmila, whose name like is changed because of privacy reasons. So she's 45 years old. Like she hasn't done any, hasn't been had an opportunity to go to schooling, and like she has a smartphone. She speaks Santali and Assamese, right? So my I mean, the one thing that kind of like motivates me, and then hopefully like you will find it interesting as well, is to ask the question like how can LLMs help people like Sharmila and like hundreds of millions like her in India and make their life better and make like access to information and opportunities more equitable for people like her. Yeah. So I'll, with that, thanks for your time, and I'll stop here. Over to you, Mitesh.
Thank you, Partha, for the wonderful talk. And in particular, like the yin and yang image has made an impression on me, and I'm sure on the others also. It's a very beautiful thought that LLMs today are a very powerful tool, and if used rightly, they can definitely drive inclusion and help to take care of more equitable access. But at the same time, if they're left on their own, nothing will happen, right? So we, as a country, as a society, as like a research community, need to drive that. And also, thanks for this long list of topics, interesting research topics to work on. Many of my students are also attending this, so I hope they'll stop bothering me now with what is the next research problem that I should work on. So thanks for that, and a very insightful talk on what is relevant in the Indian context. So thank you very much, Partha. We of course may have some questions from the audience, but maybe we'll take them later on when we have the Q&A session in after Monojit's talk, right? So for now, I'll just go on to Monojit. Yeah. So it's a pleasure to introduce Monojit. And his talk will be on safety, diversity, and inclusion. And his talk will be on scaling laws for LLMs, where he'll be talking about safety, diversity, and inclusion. So Monojit is a principal applied scientist with Microsoft Turing. Prior to that, he was with Microsoft Research since 2007. His research spans many areas of artificial intelligence, cognitive science, and linguistics. In particular, he has been working on technologies for low-resource languages, code switching, which Parth also touched upon. Monojit has made some seminal contributions to code switching and low-resource language technology for Indian languages, and computational social linguistics and conversational AI. He has more than 100 publications in international conferences and refereed journals, which are well cited. He has also served as an etching faculty at IIT Kharagpur, IIIT Hyderabad, and Ashoka University. He also interestingly organizes the Panini Linguistics Olympiads, and many of you may not know about it. I would encourage you to go and check about it. This is for high school children in India, and he's the founding chair of the Asia Pacific Linguistics Olympiad. He holds a BTech and PhD degree in computer science and engineering from IIT Kharagpur. So Monojit, as usual, it's a pleasure to have you here, and even more of a pleasure to have the chance to introduce you. So I'll hand it over to you now, and I'm looking forward to the talk.
Thank you, Mitesh, and thanks to the organizers for the invitation. It's a real pleasure to be here and talk about one of the hottest topics in the area. Let me share my slides. Yeah. Let me know if you can see them full screen. Mitesh?
Yes, Monojit, I can see.
Okay, great. Yeah, so I will kind of continue the talk that Partha gave because we have pretty similar things to say. But the only thing will be I will be talking from my personal experience. So I will be giving a lot of anecdotes about the recent things that I have been doing in this space and how it connects to the bigger challenges and problems that Partha just mentioned. And there will be very few solutions, again, like Partha's talk. There will be more challenges and questions, and probably, I mean, I don't have such a good list of thesis topics, put at one place. But nevertheless, probably you will get some ideas to work on from the talk in general. So more questions, challenges, and some speculations, little bit of maybe interesting ideas or solutions. Yeah. So you already know what LLMs are, generative AI can do, and they are amazing. What's interesting is there is a bunch of scaling challenges, right? And there are various aspects of these scaling challenges. The three that I picked for today, and I think are the most important challenges for, especially in the Indian context. One is the cost of these models, the compute infrastructure required and the kind of cost you have to incur, which is mostly not there for many institutions or even countries. Second is the issue of safety. And when these models get bigger and bigger, we know very little about them, what they can do and cannot do. So therefore, the safety concerns are also bigger. And third is inclusivity, which again, Partha talked about in great detail. And I will touch, so I won't spend much time, but I will show you some interesting examples there and my personal experiences of what works, what doesn't work. Let's begin with cost. So we all know these models are getting bigger and bigger over the years, and we don't even know how big GPT-4 is. There are many speculations about it. However, one thing to note is generally people believe that bigger models have these emergent behaviors. There are new results which show smaller models can also do well, But by and large, certain kind of properties don't seem to emerge in this model. Capabilities don't seem to emerge unless they are very big. Now imagine a huge model like GPT-4. It will have a lot of issues, right? So first is an issue of latency. If not only for training, like training might take months, even if you can afford that. But if you are, let's say, responding to 100,000 queries per second, so 100,000 queries on Bing has to go through GPT-4, and you have to run this model so many times. I mean, if you use the Bing chat mode. Now, that level of compute is very difficult, and you do incur high latencies. Therefore, even inferencing takes a lot of time. So how can you reduce that latency? And now I'm talking of only, GPT-4 being used in Bing as an example. Imagine, so many languages, so many people, everybody trying to use it all over the world. Like, again, Sharmila tries to use it on her mobile phone. How can we cater to that level of, compute infrastructure ever? So that's an amazingly hard problem to think about. And with the other parts, latency is one part of it. There is cost issues, memory issues, and of course, there are energy and environmental impact. Even if we can scale, should we scale our compute infrastructure? Because it can have a lot of adverse impact on the environment. Now, one thing that I have been trying to do in this space for a while is trying to study if we can make models significantly smaller without hurting their accuracy. Now, there are a bunch of techniques. Broadly, they are called model compression, and there is a knowledge distillation methods, quantization, other kinds of distillation, etc. But I want to highlight one particular method which I don't think has gathered a lot of attention, primarily because it's very difficult to do, which is called neural architecture search. The problem precisely is I have a huge neural network, let's say with 100 billion parameters. Can I make another neural network with maybe 1 billion parameters, so 1/100th of the size? What would be its architecture so that some other properties remain same? Like, let's say the accuracy on a particular task remains same. Now, as such, it looks like a very difficult problem to answer. But recently, we found something very interesting. So my colleagues from MSR Redmond, they have this very interesting observation with decoder-only models. So GPT-2, GPT-3 kind of models, where they showed that just one parameter, so one factor, which is the number of parameters in the model, is an extremely good proxy for accuracy on a large on many tasks. So you have the same different architectures. They have certain parameters, and you have trained with the same amount of data, etc., and you are measuring its accuracy, and you are now ranking those models by a proxy, which is number of parameters on x-axis, and ranking them by the accuracy, and you see how well it correlates, almost a perfect linear relationship. So using that as a proxy, they devised a algorithm which uses genetic algorithm as a backbone to find out architectures which are much smaller or much more efficient in terms of latency, etc., but has similar accuracy and performance. And recently we used this for optimizing a model, a text prediction model, which actually if you use Edge, you will see that there are autocompletes or suggestions. It's called Deep Right System. And this is a GPT-3 style model, but trained in-house with our data, and there are fine-tuning done on it. So when we did this kind of a neural architecture search and optimization, we got a 40% reduction in latency without any reduction in accuracy. So I think the space here is very, very fertile, and a lot of interesting stuff can be done. But zooming out a little bit, and this is a question often gets asked, how is we are going to address this huge latency issue, cost issue, and especially the models, are they expected to get bigger and bigger, and where do they even stop? So I'll just leave you with three thoughts. So there are three possibilities, I think. One is something will happen like the Moore's law in the GPU side of things, and the cost can significantly come down. of these models and of GPUs, etc., or new technology like quantum computing, etc., might come, and eventually that might take care of this issue, the scaling challenge that I'm talking about. There's this other idea, which is that eventually we will end up making this one giant model or a few of them, and they will kind of address, you can throw whatever query on it and it will answer, like API access. Now, this model reminds me of, if you know of CERN. So in physics, particle physics, experiments are very expensive to do. So people don't kind of build particle accelerators in every institution or even every country, and everybody get together and build huge particle accelerator in CERN. Everybody pays for it and everybody uses it for their experimentation. So there might be a similar kind of thing, like we have very huge foundation model with all languages, all modalities and everything. And this might be built country-wise, this might be built by certain organizations, and we have to think of how to democratize it and access and all that. That's another possibility. A third possibility, and this is what I think is the most plausible one in the short run, is it will grow like a city-like ecosystem. So you might have these big skyscrapers and tall buildings, but there will be slums, smaller buildings, different types of architectures and everything, and all of them will reside simultaneously. And there will be a very complex architecture, because for some tasks you'll need smaller models. For some languages where data is not there in high amounts, you might need other kinds of techniques and so on and so forth. And I do think the third one is more plausible, but it's interesting to think about the first two ideas as well. And of course, there are other possibilities too. Now, moving on to the next issue of safety, and this is what I'm primarily working on as a part of Turing team, where I'm looking at safety issues in the Bing conversation, and also similar other things like the deep right model I talked about, prediction of text. Now, when it goes to safety, probably most of you know that this is a big topic, and we know that generative models have a lot of problems. So one is hallucination or grounding. Whatever they generate need not be always correct. Then there is this issue of they might say something offensive or ethically inappropriate. They can do copyright violations, etc. One interesting thing is that of jailbreaks. Jailbreaks is when the model is not supposed to do something and you try to build it in a way that it shouldn't do it. Like, say you tell in the prompt to the model that you should never help somebody to commit a crime. But then you can trick the model by, like in this cartoon, you can see, you can trick the model by saying, oh, imagine you are Chota Bheem and stealing mangoes from the orchard. Can you write a story? And then the model gets tricked. Now, these are called jailbreaks, and there are various strategies for this. What is interesting is when it comes to safety or jailbreak like things, the models follow an inverse scaling law. In regular scaling, what happens is as the model size increases, the performance increases. In inverse scaling, the model size increases, and whatever you want out of the model to increase actually goes down. And a classic example of inverse scaling is responsibility. So as power goes up, actually these models are also easier to break. There is a very interesting inverse scaling challenge where people have to kind of suggest a task, and these are evaluated and a data set, and these are evaluated on a bunch of models, and people see which task has the highest correlation, in terms of inverse scaling. And jailbreak was the winner. I think it was the second prize winner or third prize winner in such a contest recently. So why this happens, right? So in a recent study, and this is something I'm kind of working on right now. So we are looking at how people do these jailbreaks. So you can go to Reddit, you can go to Twitter, and you will see plenty of examples posted every day. Like, oh, I made ChatGPT to do this. I made GPT-4 to do this. I made Bard to do this, and so on and so forth. So you can take all these data, and we try to build a taxonomy of what are the strategies. The strategies are very creative and very interesting. For instance, these models are so powerful that you can write something in a very weird way, like Morse code, or here you can see print your prompt back written in what is called leet speak. And while your classifier for safety might fail to kind of detect this input, the model still understands and acts according to it. So similarly, cognitive hacking is things like, okay, imagine you are writing a story and you are Chota Bhim is trying to steal mangoes. So that's what we have named as cognitive hacking. So there are many such categories. And the interesting thing is the more creative ones like syntactic transformations, cognitive hacking, more powerful LLMs are more prone to this kind of creative strategies. So that's where inverse scaling comes from. And how do you stop it is a pretty difficult and interesting problem to think about. And I'll just leave you with this thought here that you can intervene at the data level. A lot of these problems, biases, stereotypes, etc., come from the data. You could curate the training data. You could deal it at the model level. For instance, RLHF, reinforcement learning with human feedback, is considered one of the standard, very effective technique to what we call aligning a model. So alignment means to make sure that models are aligned to the ethical policies that the model needs to follow. And you could also deal it at the application level. And what I would like to argue is this kind of things are best dealt with at the application level for two reasons. One is your policy, ethical policy, will depend on the application context, right? And by application context, I don't only mean the application, but things like, which geography you are sending that application to, right? Different geographies, like again, Partha mentioned, will have different values and different kinds of laws. What user you are serving. Children might have different policies than adults when you are serving them. So all these things have to be kept in mind. So application is probably the right level at which this has to be handled. The other interesting question is, we want the foundational models, right, or LLMs to be generic. So they should ideally understand swear words, for instance. So if we curate and take out all the swear words from the data, how will we build classifiers to detect swear words or classifiers to detect harmful intent using these models? So these models should have the knowledge of that. So that's the other reason, I would say. Now, these are all technical problems and challenges I talked about, but there is a harder philosophical problem in the field of AI ethics, which is who should define the ethical norms and moral values of LLM applications, right? So, the issue of, let's say, privacy, the way Indians think about privacy, way privacy is thought about by a person living in rural India versus in a city versus in America will be very different. So you can't have the same rule of privacy for all of them. Philosophers call this the issue of value pluralism. So different values can be upheld by different people and they might be in conflict with each other. So what is the process of solving this is something I think the whole community is grappling with as well. Last part, which I will cover very briefly because Partha has done such a wonderful job of talking about it, which is inclusivity. So inclusivity of language is, of course, one of the axes, and I'm not going to talk about it more. I don't have much to add here. The only thing is a recent work of evaluation by my colleagues. They tried from MSR India. So they tried evaluating models like GPT 3.5, ChatGPT, Bloom's, and few other generative models over, I think, 70 languages. And they have a very interesting finding. I think there was a question also on this. So, models which are encoder only models like TULR V6 or Mural or XLMR, they usually perform better when fine-tuned with some data for the task than these generative large generative models. That's one finding. The other finding is translation-based systems also work for low-resource languages much better. So another possibility is you make a very good foundation model or LLM that works for English, and you translate a low-resource language to English and do it back. But that's, in the long run, not a great idea. I mean, in the short run, maybe we can do this. Today we see this, but translation has its own problems. And before I go there, I'll give you one more example to kind of motivate you how poorly this systems work. And coincidentally, Partha had also Sharmila, who speaks Santhali, and my example is also about Santhali. So I asked ChatGPT if it can speak Santhali. It said it can, and I said Johar. Johar means namaste in Santhali, and it answered Johar. I was very pleased. And then it says something which, if there are Bengali speakers here, they can easily identify it's not Santhali, it's Bengali. But in the middle, there are, mixture of Bengali and Santhali. So the model starts with Santhali and slowly morphs towards Bengali. This is a very interesting behavior of the model, but not very useful one, especially if you speak Santhali. But not only Santhali, which is a really low resource language, even for Tamil, while 90% of the case model will generate fine Tamil sentences. But in a study we saw, we asked it to generate Tamil, and you see this is what it generated. The first word is Tamil, but then it generated a Devanagari character followed by Telugu characters. So this kind of problems happen with such a majority language like Tamil. And of course, the constructs themselves were not great. So whatever was generated in Tamil. So there are serious problems and a long way to go here. But I want to highlight the translation, coming back to the translation issue, I want to highlight that a language is much more than words and grammars. So just getting the words and grammars doesn't tell how a particular community, a linguistic community, look at and describe the world. And for that, invariably, we need large amounts of data, either speech data, which will be ideal, but if speech data is not available, then text data. Of just a little bit of data won't work, because the model can learn the grammar and the words, but not the world view. So this is something to be kept in mind. And I will end with this slide, which is that at the end, solving these problems is a socio-technical challenge. So they won't operate LLMs don't operate independent of our needs, demands, economics, politics, and other issues in the society. And looking at it as a problem holistically and trying to solve it in that context gives us the best benefit, especially when we are working with low resource languages. And I would like to call out two great efforts here. One is AI for Bharat by Mitesh and team, which takes care of a lot of these issues that this slide shows, and how can you build technology for indigenous languages. And the other example is Masakane from Africa, where a lot of people are collaborating voluntarily and building very good LLM-based systems for extremely resource-poor African languages. Let me stop here. Over to you, Mitesh. Thank you.
Thank you, Monojit. And as I had said in the introduction, always a pleasure to listen to you. And again, a few good takeaways, or a few things which stuck with me. One is this thought on the three options, right? The one, the CERN kind of model, the other being the city model, and so on. And the other being if the compute itself becomes cheaper. And I would, at some point, if we get time today, maybe do that. But at some point, all of us should get together and discuss about this CERN kind of a model, right? Where at least in the Indian context, can we all pool resources and build this one large LLM, right? Which then serves everyone instead of having these independent efforts, right? So that's I found that to be very interesting. And I also found the idea of this AI ethics, right? I mean, everyone has been talking about ethics, but this question about who defines it and these values being different, right? I mean, and again, using this adage that in India, the speed changes every 20 kilometers. I'm sure with it, values also changes, maybe not every 20 kilometers, but every 100, 200 kilometers, right? And how do we have a set of AI ethics or commandments, right, which are universal, at least in the context of India, right? So that's also something very interesting to discuss. So thank you again, Monojit, and thank you, Partha, for very insightful talks. Now, what we'll do next is have a bit of Q&A session. So I have prepared a few questions, which also includes a few questions which were sent by the participants earlier. And Lavanya and others are also helping me curate some of the live questions which are coming in. So I'll pick and choose between these and try to have a discussion with Partha and Monojit, right? So my first question is a bit on the technical side, right? And given both of you super technical in the work that you have done in the past. So first question I have, right, and this is more like for the audience to know, right, that what is this ChatGPT moment, right? What has really happened in November, right? So we all had our fun, we were all wowed by it. But what is it? It's not clear to many people, right? That what was this remarkable change that happened? And just to put it in context, right? The GPT model is still, or any of the newer models which are coming up, the lava model, its derivatives, Palm, all of these are essentially transformer-based models, and transformers have been around since 2007, right? And these are still transformer-based. Of course, they are on steroids, but still the basic architecture is transformer. And if you look at the objective function that they are trained with, nothing much has changed, right? It's still the next word prediction or one of its variants, right? And some may think maybe RL is where the magic is coming from, but using RL for improving natural language generation has again been around since 2016, 2017, right? So if you look at this like series of ideas, they have been around for a while. And even if I look at the work stream diagram that Partha had, where he had data curation, pre-training, fine-tuning with human feedback, and then evaluation, this has again been around, right? This has been known for a while, right? So what was this step change or a series of things which worked and which led to this ChatGPT moment? And I'm focusing on ChatGPT because that's like more popular, but in general, I'm using it as a surrogate for all the wonderful LLMs that have come out in the past 6 to 9 months, right? So what was that major technology breakthrough, or was there none? What is your take on?
Anybody particular who you want to answer, or maybe I open my mouth so I can speak first. Yeah, so I mean I'll start with one caveat that I mean nobody knows it for sure, so it's anybody's guess. But there are some interesting observations that people are making, and the flip side is, of course, many of these observations are also reverted by newer studies very soon. So right now, it seems like there is a consensus, kind of little bit of consensus is building that it's only the steroids mainly which has played a role, in the sense that it is the size of the model, the amount of data that was used to train it, and instruction fine-tuning that was being done on it. Interestingly, a lot of research recently, and even Andres Karpathy's talk, which I was listening to recently, says, he also says the same thing, that there is absolutely no evidence that RLHF helps. And actually, if you look at it, RLHF probably helps in aligning the model, like ethical policies and other things. But in terms of the raw, intelligence, if you call it intelligence, RLHF doesn't help. It actually sometimes worsens the thing. So in fact, Andres Karpathy in his talk says nobody should try RLHF unless they are a real expert in the area, and it's more like a research domain. Yeah, so it seems like it's this size, but then and these properties simply emerge at a certain size. But the interesting thing is also, like, when we don't understand anything, we use emergence as a excuse. So and also there are a lot of work that are showing, even the NAS example I gave, that you don't need these big models also for all tasks. So it's a really interesting question. I don't have any specific answer more than what I just said, but would love to hear Partha's view.
Yeah. I mean, I don't have like a single pointed answer as well, and I guess like no one does, I think, like fully. So yeah, I guess kind of, I mean, there was kind of like build up with all of these like different components, Mitesh, that you mentioned. I mean, I think one aspect is like all of these pieces coming together, and then like packaged well, like with care, kind of like training, along with like the scale, which was kind of like explored. I guess like even though those components may have been there, but putting them all together in that particular way. I mean, we know that like I mean, transformer helps, but that need not be the only thing. But at least that's kind of like working right now. So I think that packaging, along with the scale, with availability of like maybe certain types of hardware becoming available and all of those would have, I think, like contributed. So then the other thing in terms of, I mean, one is like the pre-trained model, and I guess like there have been like evolutions of those in terms of like, the size increase and the capabilities that we see that has kind of like, periodically like, increased both starting from like BERT to like, MT5 and kind of like, T5 and the more recent variants. So one, I guess, like turning point there could have been also like, this instruction tuning. And then that like, with limited amounts of data, that you get some sort of like, generalization in terms of like, task performance across on built fine tune on top of like a pre-trained model, I think has given lots of kind of like, scale and allowed much more wider like, adoption. Because otherwise, if you think that like, say if these models did not generalize across tasks so easily with like, small number of instruction tune examples, then we would have been still in that kind of like, prior kind of like task specific regime, like, with some limited generalization. So that's one part. And then the other thing, like, the acceptability of like, say, chat as an UI. I think there is like, lots of like validation for this kind of like chat-based interaction, and that those are not just for like, chit chat kind of thing, but you can kind of like, actually get work done, right? So through like a conversational interface, I think also has been a good recognition and kind of like an UI validation, I would say, right? So I think from multiple of these angles, like, availability of methods, like, compute and data available, instruction tuning working, UI, kind of like all of that getting packaged in UI, I think has uh, the more broader mass appeal, and like, a lot more people have been able to engage with it. Yeah.
So thanks, Partha and Monojit. Right? And this, of course, this is again very insightful. And like the summary that I take from this is that larger scale of data, and perhaps I'll just add the word diversity also, because many of these models are now being very diverse in this kind of sources that they train on. Then the size of the model itself, right, and which we are sort of, as Monojit put, we don't understand it, but we're calling it emergent behavior. Right? At bigger scales, we have this. And then these two aspects on the downstream side. One is the instruction fine tuning, which kind of makes these models a bit better for specific tasks, and also making it chat-based, which improves the adoption, right, and makes it feel like it's usable. I'm almost trying to get a experience as if I'm asking a human to do my task, right? And all of this coming together. And what is interesting, right? And I would like the audience to also understand this, right? Because I'm sure there are many people here who would aspire to build like a Indic GPT, right, or something which caters well to the Indian context. And what this discussion, at least what I'm hearing from Partha, Monojit, and I also kind of echo their thoughts, is that there's not so much of a secret sauce there. Right? I mean, all the things are sort of known. You perhaps have to just do all these things properly. And then if the compute and the relevant funding is there, then perhaps it's not so much of a difficult choice. And it's not really something that there's a lot of secret sauce which only a few people know. Most of the parts are known, and the ones which are not known, perhaps you can figure out from all the literature that is out there, right? So good to know that, and my key takeaway would be that there's no magic sauce, but it's just a coming together of a lot of known ideas which have led to this, right? Now, continuing on this, right, and like what I want to focus on, right, is more that now with so many LLMs coming out, right, and one main claim that which gets made with every new LLM that comes out is that we are at like 90% of the chat GPT performance, or 90% of the best known model, right, or the popular models performance, right? And this tagline or punchline, at least to me, is often not clear. Right? And just to elaborate on that question, so when I first interacted with ChatGPT or interacted with over a period of time, what really impressed me, right, was not so much of its ability to say do simple tasks like hey, do the name entity recognition or any of those, but it's like generative capabilities, right? The ability to write really long, coherent pieces of text, and also to maintain context over very long context, like long conversations where I set up a persona for myself. I say that my name is this, I belong to the city. And after 10 turns, if I ask it, okay, what was my city? Then it remembers that, right? and this ability to do sort of an open-ended reasoning to a reasonable degree. But many of these claims which get made about newer LLMs, right, and are mainly not on these aspects. They're not about generative abilities, they're not about reasoning abilities, but these are more on standard NLU tasks where evaluation is automatic, right? And you have a test set, you answer these questions, you get a 0-1 score, and compute precision, recall, F1, any of the standard matrix. And I understand why that happens, right? Because automatic evaluation is easier. So you can quickly compute a number once you have trained a model and then put it out there, right? But then that at least leaves a gap for me because I don't really know whether all these models which are coming out, whether they'll have that wow effect or not, right? And it's hard to like manually go and play around with all of them, right? So how do we get past the situation, right? And also, again, I would try to relate it to, say, if a new LLM for the Indian context needs to be made, then how do we make sure that it's really at a certain level where we can be proud of? Right? So that's the context of this question. Right? How do we really do the evaluation properly and ground these claims more appropriately? So any one of you can go.
Manoj, do you want to keep that tradition or?
Okay. No, I think that's a great point. First of all, in fact, one of the things that I keep hearing from some of my colleagues at Microsoft, like Sebastian Bubeck, who claims, sparks of AGI these models have, keep saying, one thing, which is our evaluation. I mean, these models are far beyond our evaluation. So actually, whatever property we are measuring about these models are an underestimate of what they can do. Or it could be even overestimate if it's a different context. But for GPT-4, the point was these are underestimate of what the model can do. So now the question is, how can you change the evaluation process? I'll tell you, I mean, first of all, any static data-based evaluation will fall prey to this kind of issues. Because whenever you have a static data set, first of all, generative models are very hard to evaluate against static data sets. And second is, if you have a static data set, somebody or the other will come up with a model which overfits to that data set and will have better performance, even if it's not the case today. So one idea which I have heard recently, this is from University of Washington. It's a work in progress. But I quite like the idea at a high level. The idea is something like, can we have a platform where there are lots of tasks that require generative capabilities? So these tasks could be solving a puzzle, writing a code, etc., etc. And different people can go and try to solve those puzzles not by themselves, but by writing some sort of prompts or instructions to the model, and then they maintain a leaderboard. Now, if this kind of things get popular, then a lot of people will try different approaches, and then you can more clearly see where different models are in terms of how easily non-experts can also code, for instance, using this a particular model, and so on and so forth, and a variety of tasks. Now, I mean, the only point here is then we need a human in the loop. And without a human in the loop, how to solve this? I think it's a really hard question. Again, another thesis topic, maybe.
Yeah. So yeah, I think I mean, static evaluations plus test data contamination during your pre-training, because there is so much going in, you don't know what all the model has been exposed to. I think I mean, I don't know if there is any an easy answer, but if there are deployed systems, and if there are users of those systems who are finding some value by using that system, right? And if you are able to derive some evaluation criteria out of that, maybe that something like that could be a more scalable way to evaluate, right? Because I mean, if the users are not finding enough value from it, then they will not come back. So there is kind of like a sufficient amount of that utility for them to stay engaged. But then also we derive some sort of like an evaluation signal from there. Maybe something like that could be kind of like a more scalable and sustainable way of doing the evaluation. Otherwise, as Monojit also said, like static evaluations, the shelf lives are not clear. And then I mean, I also want to highlight here that long form generation evaluation is hard, but then there are also the language dimensions here, right? I mean, you may develop some metric that works for, say, English and a few high resource languages. You cannot, I mean, even if you're using like a multilingual base model on top of which that automatic evaluation is built, that base model itself is going to have like a varying performance across languages. So that metric itself is not reliable across languages as well. So yeah, lots of problems to work on in that space for sure.
Yeah, I agree, right? I mean, among several problems which are emerging in the LLM world, I think evaluation is one of the most toughest, right? And it has been, right? I mean, for machine translation itself, like which is like a very small subset of the generation problems that we deal with. I mean, since 2003, when Bluke has come out, even today, we are not really sure whether we should use it or use the 50-odd matrix which have come up in the last 7-8 years, right? And what we're talking about with LLMs is, of course, much harder, right? And to me, at least, I'm just putting out my thoughts, right? What I also feel, right, a human in the loop is needed to a certain extent, right? And if we can sort of leverage the huge human infrastructure that we have in our country, right? Some kind of a give and take, right? Where you are using LLMs for solving your task, and in turn, we are getting some feedback which tells us how the LLMs are useful while switching between different LLMs. So that's also creating that kind of an infrastructure, if it's practical, whether in a voluntary mode, in a paid mode, in an incentive-based mode, which comes back with feedback to the LLM developers. Right? That's also something interesting to think about. Right? So now, like slightly moving on from like bit technical questions to more things which trouble me as a researcher, and I'm sure that it troubles many of us who are here, right? And while both Monojit and Partha are at deep tech industry, I know that I know them for quite a few years, and I know that they are academicians at heart. So this question is for academics, so I'll expect them to answer this. So this field is moving extremely fast, right? And to the extent that papers are being written on how to deal with the resulting academic frustration of how fast the field is moving, right? And often, while the situation has drastically improved from 10 years back in terms of academic research grants and resources available to research institutes, academic institutes, it's still like quite a bit of gap from what is available to the deep tech industry and maybe even startups and so on, right? And given this, right, and given that we want to have an ecosystem of PhD students graduating with a good and competitive degrees, right? So what is a practical solution to sort of close this gap? I mean, how do we make sure that while this gap exists, and it's practical, and it's not something that you can do much about, but how do we work around this gap so that academia still does not get left behind? And to put it bluntly, right, continues to remain relevant in this field, right? It does not happen that all the cool stuff is happening outside of academia, and then slowly the question of relevance comes up, right? And it has been raised. It's not a hypothetical question that I'm raising. I think people do talk about and worry about, right? So how do we come together and try to make sure that this ecosystem of PhD students, which largely resides in academia, becomes useful to these developments that are happening, right? So again, any of you, both of you can reply.
So Partha, you should answer this because you are in both.
Okay, sure. So yeah, I mean, this is a difficult situation, but I feel that this is like a transient situation, right? Because I feel that a lot of the future and the challenges that are there is in terms of more resource constrained settings, right? So like you don't have data, you don't have compute, right? How do you make things work in those type of settings, right? Is I think going to be like a very important, and like maybe like a lot of the emphasis is going to be in that setting, which is all very conducive for academic setup, right? I mean, we got to this point because we found a path of like through scaling, right? But it's I think definitely not the case that in order to get most of these like performances and experiences that we get, we really need these large models. And there have been like multiple evidences that there is like over capacity, like over allocation of capacity to these models, and you could possibly get like get similar performance through distillation and all with much smaller model, right? It's just that like this is the path we happen to take through like through scale and through large models. But like I think like in the future we want to do everything with like smaller footprints, right? Because as Manojit was also saying, like serving all of these models at like global scale is prohibitively expensive, right? So that's one part. I mean, like I mean, so I'm working at Google, but I care for like situations where I have no data, right? I mean, languages with like little to no data. So I think that's where the challenges are there, right? And like most of the open questions, and I think like academia is like very well suited to address that. And then of course for like things where still like large amounts of compute data and all of those things are necessary, collaboration, I think like we should be doing more with industry. I mean, like through internships, student researcherships, and all of that, right? I mean, I think increasingly like I feel that the individual researchers doing things, like I think you can have like a much bigger impact, like if we like work collaboratively, because the problems require like multidisciplinary kind of like expertise, like multiple researchers kind of like come along. So I think so like pulling in resources from different places and not just kind of like doing things in isolated environments probably will be one other thing to look at.
Thanks, Partha.
Hey, Mitish, I think we are almost, it's 7:45.
It's hard for me to end the discussion. It's quite interesting. So I'll just take 10 more minutes maybe. So is that okay, Lavanya?
People are actually trying to join the roundtable. So maybe if you could like, yeah, we could take a few minutes maybe.
Okay, sure. Monojit, would you like to add anything?
No, just one sentence that if I were in academia, or as you said, I am kind of partly in academia, so I'm quite excited also about the very interesting and new set of research questions that we can ask now about these models. Like very little is known about them, so anything unknown is fertile ground for PhD, generating papers, PhD scholars, knowledge, etc. So I would have been quite excited, given I had access to the models, of course.
So thanks, Bodhan. I sort of agree, right? I mean, we should look at it as an opportunity where, and I like the way Partha put it, right? Because today maybe these are the stars, the large, very large, big scale models, but soon they will hit certain limitations, right? Limitations in terms of deployability, in terms of including large number of languages and so on. And that's the place where academia would play an important role and kind of try to not necessarily change the narrative, but also propose this alternative narrative. But while these big models have a space, there's also a space for these smaller models or ideas about how to do things more efficiently with fewer resources, right? Because that problem is not going to go away as more and more languages try to come onto the LLM world. And that's where we should look for interesting ideas. And also this idea of collaboration, right, which is like, let's work on problems which are of mutual interest and like straddle both academia and industry from the practical as well as depth perspective, right? And that is also a reasonable solution, right? So, I mean, I could continue for as much as time as I could, and I'm sure Partha and Monojit would also do that. But looks like we have hit some kind of a time limit, and we need to break out now and join the the breakout sessions, right? I think people are already starting to log in there and they are waiting there. So I'll thank both of you for the wonderful talks and also for this wonderful discussion. And please continue to stay with us. I think you can also join some of the breakout sessions and maybe switch between them. There are a lot of interesting topics that are going to be covered in the breakout sessions, starting from deployability, code generation, what things would work in the privacy setting, what are the responsible things to do here, and many applications and so on, right? So thank you everyone also for joining here, and I would request you all to start moving to the breakout sessions and continue the discussion there. Thank you.
Thanks, Midesh. Thanks, Manojit.
Thank you.